Well, welcome everyone. Lovely to have you with us this morning, this afternoon, this evening, wherever you are in the world. It's great to have you with us for part two of our webinar series. My colleague Tara Bonner is with us here on the screen, and we will lead you through our webinar this evening. You may be familiar with Tara because Tara presented webinar one of this series, and you probably have received a recording of that. So to get started, our part two of our webinar series, in this presentation this evening, what I'm going to be looking at is neuroplasticity. What is this concept of neuroplasticity? I'm going to be looking at a concept called cognitive enhancement. What is that? And then how we can take action in our lives, in work, in rest, and in play. In the last webinar, Tara talked about our brain, the most important asset that we have, and the concept of cognitive functions, which we use in our lives every single day to perceive and interact with our world. So I'm going to refer to that also later on, connect the concepts between cognitive functions and neuroplasticity. As Tara pointed out in our last webinar, the brain is amazing. It is complex. It's very, very powerful. And we know more now about the brain than we ever did before in history. And though, even with all of the knowledge that we have, it's oh so very little. The brain is so complex that we really have, a very small insight into what the brain can do. There's been centuries of work looking in the brain, looking at the brain, looking into the brain. It probably isn't surprising to know that Leonardo da Vinci was looking at the brain and studying it way back in the 1500s. Today, we use more sophisticated brain imagery, and that allows us to look at the physiological makeup of the brain, but also how it functions. Over the last few decades, there have been huge developments in that brain imaging technology, and that's allowed us to look at the brain in more sophisticated ways. And there's many, many ways that we can, look now into the brain without actually having to have a brain in our hands like Leonardo had to have. So let me tell you some fun facts that we know. There's no quiz at the end. We are born with 100 trillion synapses. We end up with 150 trillion. So we increase those synapses across our life. We generate new neurons until we die. We lose about 10,000 brain cells every day. And we also gain new connections every day. So lots happening in our brains, just as you're sitting here right now, listening to me speak. So everything's going on in our brains all the time. And, I think we go through our life without actually thinking about this amazing asset that we have. And so, yeah, it's pretty fascinating. What I found interesting, I just learned recently of this project that is happening around the world, the Human Connectome Project. Many of you may have heard of it. It's a project that's gathering data from researchers from all around the world who are mapping brain activity. So Tara may put I think I've got a link, Tara, for you to put in our chat. Well, this is the other use that we have for the chat box. Tara's going to chat back with you and put some links in there that you might find interesting. So what is neuroplasticity? It's what we also call brain plasticity. It's actually the brain's ability to change its physical structure and its functional organization in response to training and experience. So the brain can grow new dendrites. They're those little branch-like structures on the cell body of the neuron, and that receives signals coming from other neurons. The brain can also form new neural connections. It can strengthen existing connections. It can grow new neurons. It can increase neurotransmitters. All of this which fundamentally changes the brain's capacity to learn and to function. And the really good thing is, this happens right across our lifespan. So, there isn't a day where this is not happening in our brains. So it's the neuroplasticity is the connectivity between distinct areas, and also areas that haven't been connected before. So it's always, at work in our brains. I found it really interesting to learn that in 2002, the OECD countries categorized the concept of neuroplasticity as being well established in documentation, in their document, called Understanding the Brain. The OECD countries came together and looked at research into the brain and had a couple of categories. And the first category was well established. And that's indeed what they said the research into neuroplasticity was. It is well established in the literature, and because there's hundreds of credible human studies behind that. So that's really good to know. There are some pioneers in the field of neuroplasticity, and I'd like to mention a couple now. So one of the neuroplasticians, or one of the researchers around neuroplasticity, is Mark Rosenzweig. He investigated the principles of neuroplasticity in his seminal work in the field at the University of Berkeley in California. His investigations were into the effects of environmental complexity on learning and the physiology of the brain. That was way back in the 1960s. So his research with animals found that the brain which was originally believed to be rigid and fixed. And in fact, when I did my teacher training way back when, in the 70s, I was taught that the brain is rigid and fixed. So Rosenzweig actually found that it was pliable, that it was elastic, that it was neuroplastic. And he also found that you can specifically stimulate sections of the brain or areas of the brain to enhance it. And in fact, his work with rats showed that by targeting and stimulating a specific function of the brain, and he was working in the sensory areas of the brain, that the rats increased levels of neurotransmitters, had more glia cells, enlarged capillaries, more dendrites. He was proving that neuroplasticity. Another neuroplastician, or a leading pioneer in the field of brain plasticity, is Michael Merzenich. You probably have heard of him. He demonstrated that brain function and wiring of the brain is sensitive to neural activity. So activity-induced plasticity. He also explained in his work the mechanisms of plasticity. And he translated that into ways medicine can intervene to overcome brain disorders. He was also on the team that invented the cochlear implant. So really amazing pioneer in neuroplasticity. You'll find more on his work in Norman Doidge's book, The Brain That Changes Itself. Norman mentions Michael's work in chapter 3. In chapter 2 of the same book, you'll also read Barbara Arrowsmith Young's work. She had severe learning disabilities, and using the work of Luria on cognitive functions, which Tara mentioned in our last webinar, and the work of Rosenzweig on this targeted stimulation of that function, she was able to overcome her own severe learning disabilities and then create programs to help other people overcome their learning challenges. And the other person I found fascinating when I was reading Norman's book was the work of Paul Baccarita. He was instrumental in studying the idea of neuroplasticity through sensory stimulation. And I think Tara also has a link there to a video about his work, and she'll pop that into the chat for you too. Paul Baccarita's work is really amazing. He also did not only the sensory stimulation, he also did work in stroke. And you might find that interesting to read there. And also, Norman Doidge really in that book, The Brain That Changes Itself, brought neuroplasticity, what I call, to the masses, to people like me, learning more about neuroplasticity. And there is also a link there that Tara has on Norman speaking about the brain and neuroplasticity. Norman was fantastic in writing his books. So he's done The Brain That Changes Itself, and also the other one that you can see there on the screen called The Brain's Way of Healing, which looks at, exactly the brain healing itself. But he went around and spoke to all of the neuroplasticians in the field, in all various fields actually, and they're the stories and the case studies that you can read in his book. Let's go now. What are these takeaways about neuroplasticity? So a number of factors determine plasticity. We need effortful processing in any task that we're doing. If we're wanting to induce positive neuroplasticity, our brain needs to be processing effortfully. So that leads to us knowing that we need a level of difficulty and task complexity to engage our brains in the activity. We also know neuroplasticity is connected to prior experience. So what has the brain done before? And neuroplasticity also requires motivation and active engagement. So, of course, just sitting passively is not going to cause huge stimulation in our brain. We have to be motivated and engaged in the particular activity. We also know that neuroplasticity requires repetition and training. We talk about the words accuracy, consistency, and automaticity. So when we're doing a task that has a level of difficulty just above where we are currently operating, we want that task or the result to be accurate. Then we want it to be accurate, consistently accurate. And then not only do we want it to be consistently accurate, we want it to be automatic. And this is where that efficiency comes in. And this is where we can really see neuroplasticity helping us and helping our learning and making that change in our brain. Because at first, when something is new and at a level of task difficulty just above where we're operating, we are going to take time to actually complete the task. But once we become accurate and we do it consistently, then we can do it much more quickly, much more efficiently. And that's neuroplasticity in action. It is actually pushing those connections in the brain, forging new pathways in the brain. So that's really important. And of course, there is an element of receiving feedback in a task that is important as well. And something that we probably have less control over, and that is actually our human variability. We all have a different propensity to neuroplasticity. We're all individuals. Neuroplasticity then, another takeaway is all learning is a result of plasticity, and learning is inevitable. It will occur. We can't not learn. So it's important to know that as we, go through our lives and engage in the activities that we do. So let me talk briefly about brain networks. Neuroplasticity creates new brain networks, new pathways, and the important piece of information here to remember is there isn't a brain area that works in isolation. So there isn't just one part of the brain that is for reading or learning a language or writing or mathematics or walking. They are, no brain area works in isolation. So it works in these networks. So up here, of course, these are not all the networks in the brain, but these are some of the ones that we use, a lot: the memory piece, executive function network, decision-making network, language, math, art, writing, the list goes on. We also have networks that help us do tasks like finding our way around the city, by taking notes in a meeting, managing household tasks. All of these tasks, all of these activities, all of these functions that we have all use a network. And so I'm not certain if you're interested in some of those networks and what they do. But so I put these ones here on this slide. So we have the default mode network. That's a network that says, hey, I'm thinking about this. And then we have the dorsal attention network that says, what's going on here? So I'm thinking, and so what's going on? Making sense of what that is. Then there's the salience network, and it's sifting through the information. What's important in this information that I'm receiving or in this task? And then there's the executive control network that's planning how to respond. So in any given task, these networks are working together to help us complete that task. So have you ever been interested in what they look like? Well, imaging that we're getting out of the research into Arrowsmith in our students from the University of Southern Illinois, these are some of the images of those networks. That's what it looks like. Those connections, that's what it looks like. So not to explain it in depth, but I just thought, you know, if you're curious, there, there's a link that Tara will provide you to Dr. Greg Rose's work on the research that's happening. You'll hear him a presentation, but otherwise, if you're interested in any other research that's happening around Arrowsmith, it's all on our website. So it's all there for you to see. The other thing I found actually really interesting when I was learning about neuroplasticity for the first time is that neuroplasticity is neutral. It's actually not a good thing, not a bad thing. It's not positive, it's not negative. It's actually a neutral concept, because when I was, you know, learning about neuroplasticity, I thought, oh, that's a really great thing. Well, actually, it's just kind of neutral. We have control over the neuroplastic effect on our brains. So I think one of the important things to remember is that the brain adapts to what it does the most. So what does that look like? So we can do things, we have control over things in our lives that can have a negative factor, be a negative factor on our brains, or a positive factor. So on the screen there, what you'll see is what we need to do probably. It's our choice, of course, but we probably want to reduce the negative factors in our of neuroplasticity onto our brain. So we want to reduce things like chronic stress, prolonged anxiety, sleep deprivation, a fixed mindset that has us saying words like "I can't" or "I don't do that." Being engaged in non-stimulating activities, which really isn't engaging the brain. Social isolation. You know, there's been a lot of talk and research during these pandemic times around that social isolation and the negative impacts it is having on the brain. A sedentary lifestyle can be a negative effect. Inadequate nutrition and substance abuse. And I think when you're thinking about those negative factors, keep in mind this statement I made before: the brain adapts to what it does the most. So if we're engaged in those negative factors, most of the time, that will have a negative impact on the brain. But of course, we can also increase positive factors in our brain. So we can challenge ourselves, be in engaging tasks that keep our engagement, make our brain work effortfully, tasks that are complex and novel, because that engages, you know, that keeps our brain curious. And performance feedback is also really important. And then there's other factors like a growth mindset. So instead of saying I can't and I don't, What we can say is I can and I do. And there's a lot of research around growth mindset and the impact on the brain and positive neuroplasticity. As is, there's research also for the positive effect of exercise, the positive effect of mindfulness, gratitude, social interaction, proper sleep, and nutrition. So, again, we have choices about what we do in our lives. And if we really want to keep our brains healthy, if we really want to have a positive impact on our brain, we want to increase those positive factors. And again, we have control over the neuroplastic change in our lives. If just going back to Norman Doidge's book, actually, he has many case studies in his book of both sides of this equation. So you might be curious to find some of those case studies that really do explore some of the negative impacts of neuroplasticity as well as the positive impacts. What I'm going to do now is start connecting the concept that Tara talked about in our last webinar of cognitive functioning. So we have the definition of a cognitive function. It is a region of the brain or a network of regions that has a specific job or role in our lives or in the task that we're doing. So that's important to do. And then what we know we can also do is stimulate that cognitive function using the principles of neuroplasticity. And that's what we call cognitive enhancement. Tara also talked about in the last webinar that that cognitive functions work on a scale. So we all have different potentials of being able to learn new or different types of things. So there's this scale of, what we're able to do, how we're born to be able to learn those things. But knowing that neuroplasticity is possible, we don't have to sit there and say, oh, this is how my life is. This is how it's going to be. Because actually, that's that old thinking when we thought the brain was rigid and fixed. Neuroplasticity is so much more hopeful than that. So fantastic. So what we can do is enhance our capacity. So we can enhance our potential of learning, of undertaking new things, of enhancing things that we already can do by specifically targeting those cognitive functions. So cognitive enhancement allows us to be more capable, more successful, more efficient, more effective. Even at the elite level, performance can be increased, and it's happening all the time. The Winter Olympics is happening right now. That's what they're engaging to do, that practice. So again, just a reminder, we have control over this, and the brain adapts to what it does the most. This is where you need the chat box. What I'd love you to think about, and I'll give you a minute just to type into the chat box, think about what you would like to enhance in your life, in your work, in your rest, in your play. What is something that you would like to enhance? Just pop it into the chat. And then thinking about cognitive enhancement again, and I mentioned this, about the Olympics. If we can see cognitive enhancement to understand it more, we can see it through the lens of elite sport, for example. So you think about the Olympic swimmer who wants to correct a specific stroke that they're doing. So remembering the fact that the brain adapts to what it does the most. So the swimmer gets in the pool every day, practices that swimming stroke over and over and over again. Remember the concepts of accuracy, consistency, and automaticity. So that swimmer wants to make that stroke accurate, and they may do it slowly first to make sure that the stroke is correct. Then they have to do it consistently over and over and over again, and then they get faster. So that's all cognitive enhancement. That is neuroplasticity at work to enhance function. It's the same thing with elite musicians or skiers or gamers. Gamers will always say they need to do more gaming to get better at what they're doing. For readers, for writers, we say, if you want to improve reading, read, or if you want to improve writing, write. And I do give a caution there because we do know that some people find it a challenge to read and write. And then we look at, how we can stimulate function to overcome those challenges there. There are students also that really want to get into a specific program, a specialist program, or a selective high school. They practice, they are engaged, they're motivated, they're working on tasks that are above their level of attainment, just above, so then they can reach their goals. These are all principles of neuroplasticity at work in order to enhance cognition, to enhance performance in many aspects of life. So it's not just in academic work, it's in all aspects of our life that we can actually enhance how we function. There's another way we can think about it. I've talked about, elite sports people, musicians. There's also people who are really talented at certain things in their lives, like Lenny. Now, Lenny is a case study in Barbara's book. I think the page is there, page 195 in the third edition of Barbara's book. So Lenny was a gifted designer. He had extraordinary strengths in spatial and mechanical reasoning. And if you want a definition of that, it's on our website. And he had other right hemisphere functions that were really strong. But he needed to get to his goal of having a career in industrial design, he knew he needed to tweak or enhance some other functioning. So he knew he needed to enhance his ability to plan and organize. And so that's what he did. And he was able to reach his goal, and he was able to go into university, into a design course, and then he received awards coming out of university. He actually received an award, a worldwide award for his creation of a car, and he has been able to attain the job that he wanted to do. So he was engaged, he was motivated to reach the goal that he wanted to do, and he specifically targeted functions that he needed tweaked or enhanced, and that gave him that all-round strength that was able to help him achieve his goal. So it's another way of looking at that cognitive enhancement and how we can use it in our work, in our rest, and in our play. There could be a really good mathematician who wishes they could just do mental calculations quicker. So on the screen there, you'll see some of the cognitive functions that are involved in mathematics. So we have symbol relations, one of the most critical cognitive functions that we use every single day. Memory for information, so you have to remember things in mathematics. There's symbol recognition, that's a little obvious. We have to be able to remember symbols of maths. There's motor symbol sequencing, so motor planning. There's predicative speech. There's symbolic thinking, that planning aspect of solving something. And there's quantification sense. So if you actually wanted to tweak or get better at mental calculations, that's the one you'd want to enhance. You would want to enhance that quantification sense if that was the particular thing that you wanted to do. So they're the various cognitive functions involved in maths. But what if you wanted to be more efficient at juggling what we have to do on a daily basis just in our own lives at home? We have to have a number of cognitive functions working really well together. So these are some of the most the critical functions there. We need symbol relations again. It's the cognitive function that connects relationships connects concepts in our brains, symbolic thinking, the planning, memory again, and motor symbol sequencing again. These are some of the things that we need to be able to juggle all of those activities or calendars, etc., in our lives. One other thing to remember just before we move on to what you've written in the chat box, what we also want to make sure is that we have this change sustained over time. So what do we need to do to make sure that change is effective over time? So we just don't have like a practice effect. So what we need to do is we need to keep our brains active over our lifespan. We need to integrate and use the cognitive gains that we have been really targeting. So we want to use it. It's no use. There's a concept in neuroplasticity called use it or lose it. So if you don't use it, it will be lost. So you need to use that function in your everyday life. And actually, those new neural pathways will be used if you continue, really stimulating the brain as we go forward through our lives. And, I talked about this. We need to reduce the negative impact of neuroplastic change on our brains. It's, we can do everything we can to enhance it, but if we're not reducing some of those negative factors, it can really have an impact. And as mentioned, we can increase the positive factors, and that really can help that sustained change over time. So Tara, you might want to turn on your camera and your microphone and tell us, what do people want to enhance in their lives?
Well, Debbie, I wonder if you remember, I believe it was yesterday, where you said, you know what, Tara, what if people either aren't comfortable sharing, or maybe there's nothing in their lives that they particularly see as a goal or a source of opportunity? Maybe we should be prepared to share our own stories or give some examples. We did not need to be concerned about that, because our friends from all over the world, as we learned at the top of our chat, had a lot to share, and really quite poignant, I think, examples of these aspects of our life where we may tolerate, we may endure, and we may accept, but it has an impact on our lives and on the quality of our lives. So just some of the examples, I wonder, I could just start listing them. In a couple of slides ago, Debbie, you absolutely acknowledge some of the pieces that are directly related to some comments. So we had someone looking to improve their organization, someone looking to improve their memory, someone looking to improve their budgeting abilities, and then some perhaps even deeper constructs of discipline and joy and being more confident in their expression and communicating with others in written expression, but also verbally. So as Debbie has described to us, every single one of these are either specific cognitive functions, and in fact, perhaps many of you have already done your homework and have educated yourselves in some of these cognitive functions, because many of your comments directly relate to some of the cognitive functions that Debbie has described, that I described in our previous session. Others are somewhat of a composite. So as you were describing, Debbie, something like organization may fall to one or two specific cognitive functions that need to be working together. Many of you out there are parents and described wanting to help your children, either in school or in life. And so those goals themselves are very well identifiable through probably understanding someone's cognitive profile. So what are the specific aspects of a child's cognitive profile that may be contributing to their experience, their reality in school or otherwise? I know, Debbie's, the cognitive profile or the cognitive questionnaire might be an interesting spot here, but yeah, really quite moving to read everyone's thoughts. Memory, of course. And I think this is, oh, we'll have to do a webinar once we can
Yeah,
find
we
the
will.
space and time about memory, because of course this seems like this nebulous and fascinating part of our brain. And in fact, it's not necessarily a part of our brain, a singular part of our brain. In fact, much research is describing that maybe even each cognitive function has an aspect of memory. And we've had a couple of comments actually in the Q&A. Some of our friends who are seniors and want very much to continue their quality of life, and memory seems to be a particular struggle for them. So as Debbie described, there's a specific cognitive function that's memory for details, memory for unrelated lists of information, or we can remember something by deeply understanding it. Our conceptual understanding of something actually allows us to retain it, to restore it. So yeah, really quite fascinating to hear everyone's interest and curiosity. And as Debbie's described, I mean, the short answer is it, and it sounds rather simplistic, but each of you have described cognitive functions that can be enhanced. So really, I hope you feel encouraged by that, by that alone.
It's really encouraging, Tara. And, we have control over it. We can do it. That's the exciting piece. We don't have to have an external factor, oh, I need this to do that. We have control over this. We can identify, we can take action to achieve these goals, which is really, really fantastic. So thanks, Tara. Thanks for, and thanks everyone for writing in the chat.
Absolutely.
I have faith in what you were writing. Yes, it was really good. Thank you so much for letting us know that. And actually, we probably can use some of that in future webinars. In some of the webinars we have planned, maybe not the next one, but in a couple of months, there are some webinars coming up that you might find interesting in how you can, enhance those capacities for yourselves. And of course, if you have a more burning question and you need to know today, my last slide will give you a link, an email address, and you can send off an email to Tara or to some of our team, and they can help you and engage with you after that. So thank you, everyone. So here's the main ideas. It is possible to enhance our brains using the principles of neuroplasticity. We have control. We can use neuroplasticity to benefit our cognitive functioning. Our brain adapts to what it does the most. And very importantly, we can target, then stimulate and enhance specific cognitive functions. Really important. And this is one of the things I imagine and I kind of dream about. Wouldn't it be fantastic if we had a world where we enhanced our brains every single day at school, or in our workplaces, or in our community centres, or at home? Imagine a world where we enhanced our brains in a cognitive gym, just like we do our bodies in an exercise gym. Imagine a world where cognitive enhancement is part of our everyday lives. That's a fantastic thing to imagine. And in fact, in our next webinar for March, we will be exploring this concept of cognitive enhancement in education. So stand by for that one. So as we know, our brains at work, rest and play can be shaped. We can shape our own brains. As I mentioned in our March webinar, we'll be looking at adding the brain into the education equation. That might sound a little strange. Why isn't the brain in the education equation? So come back in March and we'll talk about that. And Tara can add into the chat box how you can register for our March webinar, or you'll get details when you get the recording. So as I promised, here are some email addresses that you might be interested in using over the coming days, and again, details of our webinar series. So it's time, if I can increase my screen here, it's time to have a look at the Q&A. So Tara, I'm just going to hand over to you for a second while I just fix up my screen here and get the view that I need. So I'll hand over to you.
Of course. Thank you so much, Debbie. That was terrific, and always refreshing to be reinvigorated about the power and possibility of our brains, and as you describe, of our impact, the way we can shape our own brains and quality of life. So thank you so much. There absolutely has been some questions throughout the session. So I'm going to choose, there's a few people that I'd like to follow up with via email after our session, but I'm going to share some questions that might be curious or of interest to everyone. So I hope that's helpful for you. So one really neat question that came in that I wanted to look at. So a friend of ours mentioned that they have a lifetime of poor memory and they're 78 years old. So they are wondering, and I say this with great love and respect, whether old dogs can learn new tricks. So is there an opportunity for someone, for a senior to benefit from neuroplasticity? The short answer, and Debbie is giving it through her body language now, absolutely yes. The brain is plastic throughout our lifetime. Here at Arrowsmith, we've had people in their 80s benefit considerably, significantly from cognitive exercise. And the research worldwide continues to mount to really encourage people to consider brain fitness and brain exercise to be part of daily living and to be part of a healthy lifestyle. So any of you at any stage in your life, we really do hope you consider brain health to be as important as any other aspect of your wellness. Another question, oh, this is a neat one. Why can't we exercise all functions at the same time? So happy to answer this. And a really great further dive into this area would be Alexander Luria, whose research, though now decades old, continues to carry considerable weight in the scientific community in exploring the specification of brain function. So the roles that specific brain function plays in completion of tasks, whether those be simple or complex tasks. So that holding on to that concept and synergizing that concept with the idea of targeted specification. So targeted stimulation will lead to strengthening and improved connectivity in that specific cognitive function. So if we were to, and as we do actually every day, many aspects of our brain, or perhaps all aspects of our brain, are involved in everyday intellectual activity. And as Debbie described, that means that we are constantly giving our brains opportunity to grow and to improve, to grow new neurons, new synapses, and connectivity. But if we want to improve or enhance or even strengthen a specific cognitive function, we must isolate it. So that specialized stimulation is what allows a specific cognitive function to be improved. In fact, we don't want, in a cognitive exercise, we don't want multiple cognitive functions being involved, because then they will all receive some degree of stimulation, but none will receive targeted strengthened exercise. So we really want to isolate a cognitive function so that we can tax it, in fact, even overtax it, so that it's actually growing in its capacity. I hope that helps that question. Hope that answers that question, rather. Let's see. Oh, something came from a friend of ours regarding hypnosis. Now, this is not something that is our area of expertise, but certainly in Norman Doidge's book, The Brain's Way of Healing, Dr. Doidge looks at some really interesting research surrounding that. So really recommend you find that book at your local library or online and learn a little more about that. Let's see. A number of people really curious about these exercises. So there are certainly ways that you can speak to organizations that offer these exercises, these programs, as part of a registration experience. So here in Toronto at our laboratory school and our online campus, we have staff and programs available for children and adults interested in improving their cognitive profiles. So to reach out to admissions here on the slide. There's also organizations around the world, and these are organizations licensed to offer the cognitive program that we've at least indirectly mentioned. And they have their own process of registering individuals. Some offer adult programs, others are focused in schools for children. So if you go to the Arrowsmith website and find participating sites, it's under the Parents and Educators tab. You'll find participating sites, and there you'll have the contact information for organizations around the world licensed to offer these programs.
I think we have 14 countries now, Tara, offering the program. So there's plenty to choose from. And as Tara mentioned, in person as well as online. So just contact the one that you're interested in if you want to do it online, someone that's in your time zone. Otherwise, you know, if you want to go in person, find someone, you know, a locale that is close to you, and please contact them. The other thing you can do is contact Tara. Tara knows these sites really well, and her email address is on the slide there. Please feel free to reach out to her. And as Tara also mentioned, if you're interested in our laboratory school in Toronto and our online school, admissions email is on the screen as well. Well, thanks so much, Tara. Thanks for leading us through the Q&A. And thank you very much, everyone, for your questions. We love questions. And so, yeah, really fantastic to have you with us this evening, this morning, this afternoon, wherever you are across the world. And we hope that you'll come back another time to our webinar series, remembering the next one is adding the brain in the education equation. So remember that slide I had? Imagine a world where students were enhancing their function every day at school. That's what we'll be talking about in our next webinar in March. So I hope you come back, and we look forward to more questions from you. So thank you so much, everyone. A big thank you to Emily and Sojan for being in the background and supporting Tara and I in this webinar series. They really are amazing colleagues. So thank you very much. And Tara, thank you very much for answering those questions and controlling our chat answers today. Thank you very, very much for that.
Thank you. I've been busy. It's great to have so much activity. So always a pleasure.
Well, fantastic. Well, thank you, everyone, and we'll see you next time.
Bye.